at the first stage, when this program is being converted to the machine language, it is read by the translator for its constitution, word by word. That particular program is called Lexer, and that particular stage is called lexical analysis. Once it is checked word by word, then it is checked for its syntax, sentences. And then after that, it goes through semantic analysis. Semantic means the code blocks, if they are formed properly. For example, let's say if there is and if for every if there is a next for, we might have written two ifs and one and if, things like that. Constitution of the block of code. Once these three analyses are done, lexical analysis, syntax analysis, semantic analysis, the code is now error-free. That error-free code then is converted to its machine code. That conversion is called code generation. And after code generation, when the code is generated, there is another stage which optimizes the code. That's called optimization. So all of this that is happening combinedly called conversion from high level to low level. And then we would have to study Backus-Naur form, BNF. Backus-Naur was a mathematician, a computer scientist who actually invented this form, which is used by the translators or the compilers to check the syntax and breaking up of the syntaxes so that it could understand that what you have written. Better the Backus-Naur form, better the compilers are, and there is greater flexibility of the code writing with proper BNFs. So BNFs for languages from one language to another language vary, and this variation is actually something which leads to the level where programmers decide for the languages. So those languages which are syntax strict, that you have to write this way only, there is no other way. That strictness may, what do we say? कुछ लोगों को वो annoy करती है, may annoy you, and you don't learn that particular language. But few languages like Python, they are very flexible, very flexible. They say that in Python, whatever that you write, computer finds a meaning out of it. Maybe it is wrong or it is correct, but the compiler or the interpreter is so much flexible in Python that it tries to find out the meaning of the syntax, no matter what you have written, you would see. Anyways, so this was the gist of what we are going to learn with translation software. Let us start with the key terms. All right. Key terms that we have is the lexical analysis, this lexical analysis is the first stage in the process of compilation. It removes unnecessary characters and creates tokens. What are these? We will discuss about it. So the first stage is lexical analysis. Then we have got syntax analysis. In syntax analysis, which is the second stage in the process of compilation, output from the lexical analysis is checked for the grammatical or syntax errors. Third one is code generation. This semantic analysis is part of the syntax analysis, right? Code generation. Code generation is the third stage in the process of compilation. This stage produces an object program, which is actually the machine language. And then we have got optimization. The fourth stage in the process of compilation, the creation of an efficient object program. So the program which is actually already converted to machine code, that machine code is then analyzed by the compiler so that it could be, if it could be further optimized for the speed of the program or maybe for the length of the program. If there are, let's say, few of the instructions, they are written again and again and again, तो उस सूरत में वो क्या करेगा कि उसको एक बार लिखेगा और उसके रिजल्ट को again and again यूज करेगा rather than converting it or using it or executing it again and again. Things like that, we will discuss it in greater detail. And then I talked about what? Backus-Naur form. So Backus-Naur, B-A-C-K-U-S, Backus-Naur form, or BNF. These are notations. Backus-Naur form notation. A formal method of defining the grammatical rules for the programming language. A formal method of defining the grammatical rules of a programming language. And then we have got a way of defining this syntax graphically. We call it syntax diagram. It's a graphical method of defining and showing the grammatical rules of programming languages. So if we are defining grammatical rules in written way, it is called Backus-Naur form. Obviously, this notation, Backus-Naur form notation, has got its own style of work. We will look into it, and then we can also show it graphically, which is actually called syntax diagram. And then lastly, we have reverse Polish notation. Reverse Polish notation. RPN. This polish is not in terms of polish like shining. It is in terms of polish as in from Poland. So this is reverse Polish notations, a notation which was given to us from the Poland. It's a method of representing an arithmetical expression without the use of brackets and special punctuation. So you see, basically whatever the mathematical expressions that we write in the coding or we use in mathematics, they are having BODMAS in it. They are having their own complications in it. So all those complications are tackled by us. Like first we have to solve the bracket, or we have to solve the power, and then we will see priorities or precedences and all. So what computer does, it uses RPN to remove all those issues and make the whole arithmetical expressions simpler so that it could be just executed from left to right without any of these precedences and all. We will look into it. Reverse Polish notation. So these are few key terms that we are going to use again and again and again. All right, so what I said, an interpreter, first thing is basically, if we look at this, 3.4.3 translation software, it says show understanding how an interpreter can execute programs without producing a translated version. So an interpreter executes the program, it is interpreting, it is not compiling it, it is not using machine code in terms that it is creating a file and then that file is being used. Rather, it's just a simple interpreter which is interpreting a program and executing it. There is no middle stage, there is no machine code file is formed. So a compiler does not execute the program, it is compiling. So first thing that you need to understand, that interpreter execute the program, it is written in here. Interpreter can execute the programs which it is interpreting, whereas the compiler does not execute the program. With a compiler, the program source code is input and either the object code or the error messages are produced. Means the compiler is producing another file which is machine code or object code. That file in turn is executed. In interpreter reads the program and just executes it. The object code produced by the compiler can then be executed without the requirement of the recompilation. So we may say that when we have got the source code, source code is the code that you write in the program, and if it goes to compiler, then either we have got error messages output or we have got an object code made. This object code can then be used for the execution of the program. Whereas with an interpreter, the program source code is simply input. There may also be other inputs that the program requires or to correct error in source code programs. No object code is output. There is no object code which is produced by the interpreter. But error messages from the interpreter are output, as well as any output produced by the program being interpreted. As there is no object code produced from the interpretation process, the interpreter will need to be used every time the program is executed. So what actually happened that if it is a compiler, we take the source code, we compile it, find the object code, and then we go on with the object code. This object code is actually in what? Machine form. So we can distribute it without being worried about that sometimes जब हम किसी को कोड देते हैं तो होता क्या है, we are worried that they might copy our code, they might further distribute our code saying that this is made by them, they will not actually give credit to us and all. But if it is object code, if it is in binary form, if it is in machine code form, if we give it to someone, no one can alter it. All right, so we are very free कि कोई हमारे कोड को जो है वो कॉपी करेगा, उसमें ऑल्टरेशन करेगा और अपने नाम से आगे देगा. ठीक है, सो जो इंटरप्रेटर वाले कोड्स होते हैं उसमें ये खतरा होता है. बट few of the languages in the world which are very famous, they are interpreter based, like Python. Okay, so what basically happens that for interpreter we have got source code, we have got error corrections, and then we have got program input. And then it goes to interpreter. So source code, error corrections, and the program code. These three things goes to interpreter, and then interpreter might give you error message. Or the program output. No object code. Okay, so as you can see, this is the difference. Compiler only takes source code and gives error messages and does not produce object code. There is OR in between these two. Okay, then you rewrite, correct, or whatever you do with the source code, and you keep doing it until there are error messages which are being produced. Once all the error messages are removed, code is corrected, then you find the object code. That object code does not require any of the compilation again. That object code is the machine code and you can use it to execute the program. Whereas if it is interpreter, we know that there is no compilation, so we run the program, that interpreter then requires that program in the form of source code. If there are any error corrections, we keep doing it, and the program, since the program is also running or being executed all along, so we are actually giving program inputs as well. While that is happening, if system is producing error messages, we know that interpreter just stops there. We go back, we correct the source code, we do error corrections, and then we rerun the program, and again we give input, and then interpreter executes that program. If there are error messages, it gives error messages. If there is no error message, program gives output. So even after giving output, there might be errors further, so system will again give you error message, and you go back to source code, correct the error messages. Messages are corrected, and then you again execute the program and give input, and this is how it works. So we need interpreter every time when we require this program to be executed. Both the compiler and interpreter will construct a symbol table. If you do remember symbol table from your chapter 4 in P1, paper 1, symbol table, where it keeps the tally of all the labels and their respective memory addresses. Symbol table, that is called symbol table. We will look into symbol table once again. Both the compiler and interpreter will construct the symbol table, and interpreter will also allocate space in memory to store any constants, variables, and other data items used by the program. So it would actually be allocating a space in the memory, because otherwise these things cannot be stored. The interpreter checks each statement individually and reports if there is any error, which can be corrected before the statement is executed. After each statement is executed, control is returned to the interpreter so that the next instruction can be checked before the execution. So we can actually uh, simplify it, we can summarize it, the differences between the interpreter and the compiler. Let me show you one of the slide from O level and AS level that will actually help you to understand. Hold on. We have got high level languages, low level languages, and their translators. Okay. So high level language is a language which can be understood easily, like A is equal to B plus C, whereas low level language, same is happening. LDD, this is not LLD, this is wrong. This is LDD. LDD B at C and then store at A. So this is simple, that high level language can be written in short, whereas in low level languages we have to write more. Okay, so these two are doing actually the same, but high level language is doing it with just one statement, whereas in low level language we have to write 3 instructions. Okay, now so languages can be divided into two: high level languages and low level languages, and their translators are required because at the far end the processor requires everything in machine code. So this high level languages translators are either compiler or interpreter. We just discussed about these, and low level language translators are assemblers that we have studied in P1. Now, assembler turns everything into the machine language, machine code, and the microprocessor then executes that machine code directly. The file that is produced by the assembler is having the extension .com, the command file .com. Whereas if it is high level language, the translators are interpreter. Now interpreter is itself the shell or emulator of the program. It is the virtual machine. We will discuss what virtual machine is. In simple words, virtual machine is a software which is depicting a hardware. So it is actually depicting itself as hardware, and it is executing the interpreter. The interpreter itself is executing the source code program, and there is no any file which is produced. Whereas if it is compiler then produces the machine language or object code. The extension of that exe file, if you would have ever noticed, whatever the software that you install over the desktop or laptop is having the extension .exe. If it is Microsoft Word or Excel or whatever, they all have got what? .exe file. That exe file is basically the file which is the object code or machine code. And then that exe file or the COM file ultimately get executed by the microprocessor. Okay. So there is no file created by the interpreter. Interpreter just executes the program line by line, whereas the compiler, it takes the file, produces this object code or machine code, and then the processor executes it. So for interpreter, if you want someone to use your program, you would have to hand them your source code, whereas in compilers or assemblers, all you have to do is to give people your object code or machine code, and then they will just execute it. All right. Just suppose that what if Microsoft Word, they would have made it in a language which is interpreter based, and then every time you want to use Microsoft Word, you would have to purchase the source code. That doesn't happen. What they give you? The machine code. Anyways, so what is the relationship between the machine code with reference to the machine code between high level languages and low level languages? What is the relationship between these two? So high level language, for every high level language is one instruction, there might be several machine code instructions. For one high level language instruction, there might be several machine code instructions. So this relationship is called one to many. So when you write the program in high level language, you write short programs, and these programs and compiler turn them into, when compiler turns them into the machine language, there might be several instructions for one high level language instruction. This is called one to many. Whereas if it is low level instruction, low level language like this, ADDC at C, so this is one instruction and its machine code would be still just one instruction. The difference would be that this is in the form of mnemonic, opcode and operand. In machine code, this opcode and operand would be in binary. So for every single assembly language instruction, there is one equivalent machine code instruction. This relationship is called one to one. And then the difference between compiler and interpreter in terms of differences. Compiler consumes the whole source code. Interpreter consumes one line at a time and executes it. Compiler does not execute the program. Tough to debug. Obviously, when compiler compiles the program, it is not executing it. So if there are errors, it does not stop. Since the interpreter is executing the program, there are errors, it just gets stopped there and tells you to correct the program. Once you correct the program, you have to rerun the program from the start, give input and reach to that point where the error found out last time, and then you pass that point onwards, and then if there are further errors, that program goes this way. But if it is compiler, since it is not executing, it does not stop. What it does, it just gives you the error and goes on and on and on until the whole source code is read. So you need to understand that if there is an error, compiler is not stopping, it is going on with that error. In that case, what will happen, that error might produce further errors. This is called cascade effect. Cascade effect. So what basically happens, one error produces other errors produce further errors. So at the end of the compilation, if there are errors, you would have so many errors that it will become tough to debug. There used to be a teacher of mine, Sir Abdul Rashid. He used to say that do not try to correct all the errors if it is compiler, just try to correct top 2 or 3 errors and then recompile. Once those top 2 or 3 errors are finished, many of the errors further are gone by themselves. Okay, so compiler is tough to debug. Whereas interpreter, since it gets stopped wherever the errors are, it is easier to debug. Compiler generates .exe file, whereas interpreter works in emulator. Emulator is actually the virtual machine which actually behaves like the processor itself and just executes the program. And then we have got what? No copyright issues. There would be no copyright issues because no one is going to copy your machine code. Since machine code is not alterable, it is all in binary, people are unable to change them. But if it is interpreter, you would have to hand in your source code. And if it is source code, they might change the source code, they might name it on their own name and all. So there are no copyright issues, there might be copyright issues. Runs directly over the microprocessor. Since it runs directly over the microprocessor, it might crash the system because it can hang the microprocessor and it can crash the system. Whereas over here, it does not crash the computer because it acts itself as the emulator of the microprocessor, executes the program itself, and it would not actually crash the system. All right. So these were two things that you need to understand at the moment. And then we have got this idea that compiler takes a lot of memory, whereas interpreter does not. Obviously, see, compiler is memory hungry. Why? Because it loads itself. The whole compiler is in the memory. Then it takes the whole source code, and then it requires the space to convert that source code to the machine code, and then that machine code is also in the memory. So it is loaded itself, then it loads the source code, then it requires the space to convert that source code into the machine code, and ultimately the object code or the machine code is also loaded. When the compilation is happening, the computer requires a lot of memory. So, people usually think that this interpreter was was something which was produced first to convert the programs into machine language as an interpreter. No, that is not true. Compilers were made first. Since compiler require a lot of memory, and back in 60s and 70s, the memory was actually really expensive. So people gave up on it. So when people did not pay any um, heed to the compilers and they did not show any interest in it, then these companies came up with the idea of interpreter, and then they started using interpreters. So compilers were made first because they were memory hungry. They require a lot of memory. Memories were actually expensive, so people gave up. So in order to bring people back into programming for certain languages, they started making use of interpreters. So that is one short discussion about the compilers and interpreters. Now, let's get back to our previous work. Now, stages. Now the second point, stages in compilation of a program. Stages in compilation of the program. Stages in the compilation of a program. Okay, the process of translating a source program written in the high-level language into the object program in machine code can be divided into 4 stages. The first one is lexical analysis. All right, what's that? Lexical analysis. So we have got source code. Okay, that source code goes through several stages. The first one is lexical analysis. So what lexical analysis does? Lexical analysis is the first stage in the process of compilation. All unnecessary characters are removed. All unnecessary characters are removed which are not required by the compiler, such as white spaces and comments. So what are white spaces? White spaces are any of the enters, any of the tabs, and comments. We know that remarks that we put inside the program. So these are not required by the microprocessor. We do indentation. So between for and next, we indent the code. That indentation is for the improvement of readability. They have nothing to do with the compilation of the program or the execution of the program. So they are removed. They are not removed from the source code. They are removed from the analysis part, means they will not be judged. And similarly, if you would have put some comments in it, these comments will be removed. So that is what the lexical analysis first does. And then let's say we have got we will be solving few of the past paper questions which will require us to do this. Means whatever that we are studying now, we will be implementing it. Okay? So pay attention to everything. Before translation, the source program needs to be converted to tokens. So it generates tokens. Okay. This process of turning the program into tokens is called tokenization. So basically, what lexical analysis does, we have to pay attention to the details. See now. So basically, what happens at lexical analysis, hold. So let's say if it is lexical analysis, what basically happens that we have got source code, that source code, first the white spaces, and comments are removed. All right. And then what are these white spaces that we have? We have white spaces in terms of carriage return. You know what carriage return is? That is your enter. We have got line feed. Line feed is actually going to the second line without having enter in it. So when we are typing in Microsoft Word and we enter, it changes the paragraph as well as the line. But sometimes we don't want to change the paragraph. In the same paragraph, we want to get to the next line. So we don't want to change the paragraph. For that case, what we do is we use shift enter. So shift enter only gives us line feed, not the carriage return. Okay. And then what we have got tabs, and then we have got any additional spaces that we have entered. So combinedly, these 3-4 things are called white spaces. All right, and then we have got comments. We remove those comments. Now, after removal of these white spaces, what system does? system evaluates every single word. So all of the words, so this the word lexical is coming from the word uh, lexicon. Lexicon is about words. All right, so the words are being checked. So now there are two types of words. When we write program for the compiler, there are two types of words which are known. All of those words which are the part of the program instructions, statements which are given by the program, the language itself, is actually known words. So those known words are found in a table which is pre-given, already given. That table is called keyword table. What do we call it? Keyword table. So we have got keyword table here. Keyword table. This keyword table has got two parts, the keyword itself and a token. So these words are actually checked against known words. Known words, those words which are known words. So what are tokens? Tokens are actually numbers assigned to these keywords. Numbers. Tokens are 16-bit unsigned integers. Tokens are 16 bits unsigned integers, means these actually are the integers in 2 bytes. All right, so every single word which you have written will be assigned this tokens. Means every word will be converted to a number, a binary number, which is 16-bit unsigned integer. And these are basically tokens. These tokens are the output of Lexer. Lexer is the program which is doing this lexical analysis. Output of the Lexer and become input of the parser. Parser is basically the next program which does what? Syntax analysis. So lexical analysis is done by Lexer. Lexical analysis is done by the Lexer. Of the parser. Okay, so you have to keep that in mind. You might be asked for it that what are tokens? Tokens are 16 bits unsigned integers. They are the output of Lexer and become input for the parser. For what parser does, it does syntax analysis, which is the second stage of it. So every single keyword is having a token. Okay, so keyword and token table. What do we call this table? We call this table keyword table. Okay, so this keyword table is actually predefined by the language. Okay, so it is predefined by the language. So if the word which was found if the word which was found is present in keyword table, it means that this is a word of the language. Now let's say if I have written dim a as integer. So dim is the word which is known, a is the word which is unknown, as is the word which is known, integer is a word which is known. So out of dim a as integer, these 4 words, 3 words are coming from the keyword table. So these words will be found in the keyword table and their tokens will be passed on. But this dim a, the character a is actually representing what? Character a is actually representing a label, a variable, okay, maybe a constant or maybe any other name which is made by us as the programmer. So that, since that is made by us as the programmer, that is not known. So there, then the compiler produces what? The symbol table. So this symbol table has got so many things. First of all, the label itself, the name. All right, label or name. Then it has got type. What type of uh, okay, what type of variable that you have produced? What is the scope of the variable? Maybe the size of the variable, and there are so many things. But you have to remember just one thing: at this particular moment of time, when the lexical analysis is working, symbol table only put the data in terms of name of the label itself. Okay, so this symbol table is produced. Name, type, scope, size, whatever. That is all put in this table, but it is actually updated at later stages of the compilation. At this particular stage, only the name of the variable is saved. All right, the type, scope, size, everything will be filled later. This particular symbol table is random access table. It is actually random access table. Means it is not serially searched, it is randomly searched. Whatever the label that is required is found directly. We will be discussing this random access as a topic in A2 further. And it is supposed to be a hash table. Hash table is a data structure that we will be studying this year in data structures. So I'm leaving it for that particular topic. And then hashing. Hashing means adding data to the hash table by an algorithm that is called what? Hashing. Hashing is done based on the name. Hashing is done based on the name or the label. So in short, what is happening? System takes the name, I'll apply the algorithm to it, find a location where that algorithm is giving the output, and that location is supposed to be the address of that particular label in this list. So let's say if this list has got 100,000 names in it, system will, whatever the location that system requires to fetch data from, it will take that name. So what basically happens कि हम जो variables होते हैं, variables को नाम देते हैं. Variable के जो नाम हैं, those names of the variables are actually representing the memory locations. So those memory locations are listed here. If you want to fetch one of the variable, you have to know the location of that variable in the computer's memory. And now this computer's memory is a vast C. if you go on with that table again and again, every time you require to fetch a variable, it will take a lot of time. So that is why system uses what? The random access method. Random access method allows you to have the name, apply the algorithm over the name, algorithm finds you out the address, you go to that address and find the location. So what is that address? The address of that particular label in the table. Let's say I've got 100,000 names in the table. So I'll take one name, Zafar. I'll apply, I will give that name to the algorithm. Algorithm will give me 58. So I'll go directly to 58 to see that what is information related to Zafar in the table. So this random access table allows you to go to a particular name directly rather than scanning it serially. Okay, so this is called random access thing, and all these three are part of random access. The table is hash table, and hashing is basically doing whatever I have just explained, and that is based on the name. Now, sometimes what happens when the algorithm generates an address in the table and you want to save the name at that particular address, and that address already has a name or label saved in it, that is called a clash. So there are clash resolution techniques over here. Chaining technique is used to solve clashes. So this is a whole different topic. We will look into it. This is random access method plus hashing table, and hashing is a separate topic. We will look into it. So now let's get back to our topic, usual topic. So what is happening in lexical analysis? Source code is taken, white spaces and comments are removed. What are these white spaces? These are the carriage return, means the enter, line feed, and tabs and spaces. Then the words are then analyzed, every single word. So if the word are known, they must be found in the keyword table and their token is sent, okay, to the next stage. If the words are unknown, if the words are unknown, system or compiler creates a symbol table. That symbol table is then filled over the name, and their token also are generated, and then those tokens, which are generated tokens, are actually sent to the parser. So if it is symbol table or if it is keyword table, from both of them, what do we find as the output? Tokens. Keyword tables tokens are already there. They are predefined, but the token for the symbol table are assigned on the go. So this is called what? Tokenization. What's happening? Tokenization is happening. So before translation, the source program needs to be converted to tokens. This process is called tokenization. In order to tokenize the program, the compiler will use the keyword table that contains all the tokens for the reserved words and symbols used in programming languages. I have given you example. One thing that you have to understand, sometimes there might be exceptions to this particular knowledge. In that case, what will happen, that whatever that appears in exam would be understood, but that would not be exactly the way I am explaining it. All right. So you do not need to rot learn this. You have to actually learn this idea that is, this is all what is happening. Okay. Sometimes there might be exception to it. There might be, they might, like, let's say they might say that there is just one table and that table has got keywords, and symbol table symbols all together. So in that case, you would understand, yes, sir taught us that these are two different tables, but now this paper is saying that these are combined tables, so it doesn't make any difference. Okay, but you need to understand that these tokens from the keyword table and the symbol table, they are put in one table, and that table is being transferred to the parser. All right. All right. Sometimes the term fixed symbol, uh, fixed symbol table can also be used for the symbols stored. Every program being compiled uses the same keyword table. So keyword table is basically there. During the lexical analysis, the variables and constants and other identifiers, we know what identifiers are. Identifiers are any name that are given maybe to the procedure, to the function, the program, the constant, structure that is made by us, or the variable. So whatever the name that you choose is actually called the identifier. So during the lexical analysis, the variables and constants and other identifiers used in the program are also added to the symbol table. All right, so let's solve a question so that you get the whole idea of lexical analysis in one place. Okay, hold on. मैं वो क्वेश्चन निकाल लूँ, थोड़ा सा वेट कीजिए. चलें जी, ये पेपर है 089608 paper 3-2. Question is 4. Question 4. A compiler uses a keyword table and a symbol table. Part of the keyword table is shown. Tokens for the keywords are shown in hexadecimal. All of the keyword tokens are in the range 0 to 5F. 0 to 5F. Entries in the symbol tables are allocated tokens. These values start from 60. So 0 to 5F is allocated for the keyword table, and for the symbol table, entries are starting from 60 of hexadecimal. Study the following code. Complete the symbol table to show its contents after the lexical analysis of the stage. So first leave this. Let's first pay attention to this. So let's say we want to generate tokens. We need to do tokenization. All right. So let's study this code. This code says what? This code says input number 1. So we can see that this word input is actually here. So which token is generated? 51. And then we have got what? Number 1. Number 1 is actually a word which is given by us. It is an identifier. So they say that identifiers are starting from 60. So this is 60. This is second token. Then we have got input. Again, it is 51. And number 2 is actually now 61 because we have used 60 for number 1. So number 1 is 60. This is 61. Now, input again. So this is again 51. And then we have got what? Answer. So we will allocate 63 hexa to answer. Now we have got what? If. Remember, we are doing lexical analysis. Lexical analysis is about words. So we will be analyzing every single word. If is here, 4a. If answer is 63 is equal to is 03. Number one is 60 plus it is 02. Number two is 61. Then we have got what? Then we are ignoring all these spaces and all. Then we have got then is what? 4b. Okay, and then we have got what? Output. We are ignoring any spaces, tabs, enters, whatever. Then we have got output. Output is what? 52. Then we have got 10. 10 is a constant. So constant, we have to have the next identifier by the name 10 in the symbol table. So this would be 64, 6 and 4, sorry. Else is what? 4D. And then we have got what? Output. Then we have got what? Output. Output is 5-2. And then we have got 0. So 0 is the next one, 6-5. And then we have got what? And if. So and if is 4C. So this is tokenization of the program given. Study the following code. So you have studied the code, ignored all the spaces, tabs, new line, carriage return line feed and all, and you have generated tokens for every single word. Where it is found in keyword, you have taken the token from the keyword table. Where it is not found, you have this knowledge that they said that the values start from 60 hexadecimal in what? The symbol table. So you have used your own tokens in the series which is given from the 60. If it is constant, you have used the next series number. If it is a variable, whatever variable or any name, we used subsequent numbers in the series. Anyways, now what it says, complete the symbol table to show its content after the lexical analysis stage. So what are actually the symbols that we used? अब देखें इसमें हमने यूज किया था number 1, number 2 answer. Answer is a variable. Then we use what? Number 1 answer, number 1, number 2 output 10. 10 is a constant. And then we have got what? 0. 0 is a constant as well. And answer is 63, and then we have got what? 64. That is exactly they require us to do. That is exactly what they require us to do in here. So we have got how many unknown words here? We have got this number 1, number 2 answer, this constant and this constant. So 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. All right, let's solve another question from another variant. Hold on. All right, let's solve this question. Question number 6 in 3-1, same year. Question number 6. Let's see what this question says. This question says somewhat the same thing, but they want us to go further. Let's see. Now, the compilation process. So this is winter 18, P31. Okay, the compilation process has a number of stages. The first stage is lexical analysis. A compiler uses a keyword table and symbol table. Part of the keyword table is shown in here. It is somewhat same as what we saw in the previous question. A compiler uses a keyword table and symbol table. Part of the keyword table is shown. Tokens tokens for the keywords are shown in hexadecimal. All of the keywords tokens are in the range 0 to 5F. Entries in the symbol table are allocated tokens. These values start from 60 hexadecimal. All right. So study the following. Now pay attention. It has got this comment. So we will ignore it. All right. We have got these tabs. We will ignore it. Okay. And rest everything will actually be taken into consideration. Now, what are the entries for symbol table? So this start is an identifier. This is a constant. This number is a constant. This counter is a constant. This 12 is a constant, and number, counter, and that's about it. So we have got a start. We have got 1. We have got number. We have got counter, and we have got 12. Start 1, number, counter, 12. Okay. Start 1, number, counter, and 12. Start 1, number, counter, and 12. So number is variable. Counter is a variable. 12 is a constant. And this is 62, 63, and 64 in hexa. So we have completed it. Now, they say the output from the lexical analysis stage is stored in the following table. So this is a table combined. This is the tokens table. Each cell stores 1 byte of the output. So they say that their tokens will be of 1 byte. Complete the output from the lexical analysis. Use the keyword table and your answer to part A. And not, let's just find the number. So how many, oh sorry. Let's just find out how many places are there so that we have an idea that how many tokens are produced. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right. 16 places that we have. And then we have got start. Start is 60. 61, 62, 63, 64. So let us start. So first we have what? Start. Start is 60. Then we have assignment symbol, which is 1, 0, 1. Then we have got 1, which is actually 6, 1. Then we have got input. Input is 5, 1. Then we have got number. Number is 6, 2. We ignore all of the comments. We go to for. For is 4E. Then we have got counter. Counter is 6, 3. Then we have got assignment. Assignment is 0, 1. Then we have got start. Start is 6, 0. 2. Then we have got 2, that is 5, 0. Then we have got 12. 12 is 6, 4. We go to the next line. We have output. Output is 5, 2. Then we have got number. Number is 6, 2. Then we have multiplier symbol. Multiplier symbol is basically 0, 2. And then we have got counter. Counter is 6-3. And then we have got end for. End for is 5-3. Combinedly, they have to be 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So you have to fill in these values over here in this 61 and all. So you will get how many marks for it? 2 marks for it. Okay. So this was the question. Next part is related to syntax analysis. We have not studied it now. So let's just call off the class. If there are any questions, please do ask those questions. Let me see what you have understood and what you have not.